Yes.
Okay, we went through the different, we said we do have different types of attacks at different layers of the OSI model. Okay, we looked at the physical layer. What are the different attacks that can be found here? We talk about device tampering, eavesdropping, jamming, cyber, and path-based DOS. Then we moved to the data link layer. We looked at the different types of attack that can be found at this level. We talk about the node outage. We talk about collision, resource exhaustion, traffic manipulation, acknowledgement spoofing, unfairness, sinkhole, impersonation. Okay. Then we looked at the wormhole, where we said that you do have two attackers, two nodes that belong to the attackers now are involved, because usually on the previous attacks you do have only one node, but in here you do have two nodes of the attacker that have been placed in specific location, and those two nodes will create tunnel between them. The tunnel will have the characteristic of being with low latency when icon asra, okay? And when other nodes will discover that there does exist another path which is faster than the one they are using, they will utilize that path and they will start sending their data to those nodes that are the starting and end of that tunnel, and they don't know that those are malicious nodes. In the network layer, we said many things are based on the path, how an attacker will play with the path that is used in the routing. Okay, we looked at which is known as based on the false routing, where we do have overflowing routing table, poisoning the routing table, and also poisoning the routing cache. Okay, these are a part of the network layer, and also we do have a packet replication, black hole, where you will have everything will be dropped. And we said here it is very important for the attacker to locate himself just near the base station. Otherwise, if he is in the other place other than this location, that means he might not be chosen as let's say, or the packet or the messages exchanged between the sensor nodes and the base station, it might not pass through that node. Maybe if, for instance, if it is here, maybe it will just receive the messages from these two nodes. But what about the others? They will use another path. So placing himself in this location, that means everything should pass through that node in order to reach the destination. And once it is in the attacker node, it will be dropped. Here we talk about dropping those packet, everything. If you do selection, I will drop some and let some. We talk about selective forwarding. You will forward only something that is based on some criteria. We do have now some attacks that are categorized and their transport layer. We do have two types of attacks. The one which is known as desynchronization flooding, okay, and with desynchronization, we do have the second one, which is a flooding. Desynchronization, we talk about an established connection. When we do have an established connection between two nodes, between two sensor nodes, okay, and they are communicating to each other. So what the attacker will do, will try to desynchronize that connection. Okay, that means it will try to disconnect that already initiated connection between those two nodes by just sending some request to both nodes, or to one of them, asking that sensor node to initiate communication with that attacker's node. So that node, it is already in communication with another node, that just to destabilize that connection. So the attackers will send request to establish connection with that node, and sometimes the attacker will send request to establish connection with both nodes individually and separately. Okay, and of course this will disconnect and desynchronize the already connection between those two nodes, and on the top of that, when those nodes receives the request, okay, that means they will listen to that request, they will receive the request, and they are just by receiving and looking at that request or reading that request, they are also wasting their power, and the power are depleted. Okay, so this is based on, let's say, an attack that is based on the transport layer, because we are dealing about the connection. Flooding, the same thing. Flooding, instead of using sanding, for instance, for the desynchronization, you are looking for a connection that has already been made between two nodes. Now, in the flooding attack, what you will do, you will send that large number of requests to establish a connection with some specific node. Not necessarily they have already been in communication and with other node, but you will just flood specific. Let's say if you pick up one node and flood it with the request, a large number of requests to establish connection with it, with that node, that means you are depleting, you are making that node to deplete its energy, to lose its energy. Okay, just because it is receiving large number and it does have to deal with such a huge number. Okay, that means you are pushing it as to listen and process the request. We don't care about whether it will accept it or not, but just by processing, you are just trying to deplete the energy of that node that has received that flooded number of requests for establishing connection. We do have another types of attacks, okay, in the application layer. Okay, these are the number of attacks that can be found in the application layer. We're going to see each one of them individually, quickly. Okay, here we talk about in the application layer, what is needed by the attacker is to know specific the semantic of the data, the meaning of the data, in order to manipulate the data. Because let's say we are talking about the application layer, we're talking about the data itself. We need, the attacker need to understand the data, how the data is processed, what is the format of the data, in order to be able to launch attack at this layer. Okay, the first type of attack, which is the clock skewing. Clock skewing, here we talk about specifically with the network where you do have those sensor nodes. It need to be synchronized. They need to have the same timing. Okay, for instance, every sensor node should have the same timing, and usually in the network, for instance, you get the timing from a server. It will be a network time server using an NTP protocol in the network. The server will send the correct time and date to all the nodes within the network in order for those nodes to adjust their clock and date. Okay, and it is very important with regard to the timing in the network, because, for instance, let's say you do have a router, some routers, and the router have some rules that will have firewalls that will prevent, let's say, some specific packet from specific time, from 9 to 12. Let's say from 9 to 12, no one can access the internet. But if someone will reach the network, will reach that firewall and place with the clock of that firewall, will place with the clock of the router and change it to an afternoon. Let's say now, for instance, we are 10 in the morning. So let's say the guy or the attacker will change it to 10 in the evening. That means if a packet comes to that router and finds that packet is of internet, and is it permitted or denied, it says if it is in the morning, deny it. He checks his clock and finds that it is evening, so it will let, or that firewall or router will let that packet to go through. And sometimes in WSN, in some circumstance, those nodes, sensors nodes, need to have some type of synchronization. They need to have the same timing, okay, for some specific purpose. Okay, what does an attacker do? The attacker will try to change the time of some of the node and desynchronize them. Okay, this is what is known as what we mean by a skew their clock. That means it will change, okay, their clocks from the right timing to the wrong timing in order just to desynchronize those devices. That's why we said we need to know that information. We need to know the format of the time in order to be able to send them wrong timing. This type of attack is known as clock skewing. We do have data aggregation distortion. If you remember, we said that sensors will collect the data, okay, and that data will be sent to the base station. So what does an attacker do? The attacker will maliciously modify that data that will be aggregated by the base station, okay. Then the base station will send that data to the server or to the cloud to be analyzed, and based on the analysis, as we mentioned, some commands will be sent back to control some devices in, let's say, an environment. Because the data was maliciously changed and modified, that means the gateway will send that changed data, and of course wrong decision will be taken based on that data. Okay, this is what is known as data aggregation distortion. We do have a privilege escalation. Okay, when someone will gain access to some devices without having, let's say, the correct privilege. He did have, let's say, user privilege. By managing with some vulnerabilities, exploiting some vulnerabilities, he managed to get, let's say, the credential, okay, from user to administrator, where he can do many things having such credential. Here we talk about credential theft, someone who is stealing the credential of some specific computer or device just to try to do whatever he wants to as an attack towards those devices. Repudiation, that means you cannot track any attack. Okay, there will be no control of any track of attack, for instance, that has been done by any user. Okay, this will facilitate anyone with malicious intent to do any malicious task and action on the WSN devices without being traced or being accountable. And however, we have already talked about the buffer overflow in the previous chapters. This is also one of, let's say, the attack that can be done where you will find an attacker will try to send to flood the buffer of a device until it goes to another, let's say, location in memory, and maybe those messages that are part of the flooding will contain some instructions, malicious instructions, and those instructions will be executed by the devices. Cross-site scripting, okay, taking advantage of having access to, for instance, to the devices, to the cookies, to the session tokens, for instance. You will find someone who will inject some malicious script into the website, okay, just within the website, within script of the website HTML, someone will put malicious code. So where that website, when that website will be loaded, it will execute that malicious code. Canonicalization, here we are talking about you receive data, you got the data, and you send the data to, for instance, replicate the data to those sensors node, but the format of the data will be changed. Okay, you will have some, we call it by malformed representation. That means you are not going to send data on its correct format. It will have a different format, and the device will now doesn't have, for instance, the way how to deal with such malformed data. Just by changing the extension of the, for instance, the data or the file, maybe there is no application, or a corresponding application that will be able to read such, let's say, a file. And this is one types of attack that is that can be found in the application layer. So we conclude our chapter. If you have any questions about with regard to this chapter. Yes, Shabab, any questions?